Hello students, welcome. So today we are going to start a new unit, Unit 7 Equilibrium. In chemical reaction, we have multiple type of things going on. And for to understand those things, we need to understand different branches of chemistry. As for example, if you want to find out the energy related discussions or energy related data, then you have to discuss thermodynamics. Similarly, if you want to find the data related to energy in terms of electricity, then you have to learn about electrochemistry. So, if you want to find nature of reaction and up to which extent it will complete, that means what is the amount of product obtained after the reaction is completed, then we have to learn about equilibrium. So, let's start our unit. So first let's talk about the objectives. So first point, identify the dynamic nature of equilibrium involved in physical and chemical processes. Now dynamic nature in the sense these reactions when they are complete they are not steady or static but they are actually in moving position. That means still reactions are continue but concentration remains constant. That means concentration of product and concentration of reactant remains constant, and it will appear that reaction is static or steady but it is actually in motion. That's why it is called dynamic in nature, and we will discuss about it in detail. State of law of equilibrium. We have different laws to understand for equilibrium. Explain the characteristics of equilibria involved in physical and chemical processes. Write expressions for the equilibrium constant. Establish the relationship between Kp and Kc. Now K are equilibrium constants. P represents pressure, that means for gases, and C represents concentration, that means for solutions. Various factors affecting equilibrium constant or state. Classify substances as acid, base according to Arrhenius, Bronsted, Lowry and Lewis concept. Classified acids, bases as weak or strong in nature of their ionization constant. Explain the dependence of degree of ionization on the concentration of electrolyte and that of the common ion. Describe pH scale for the representing hydrogen ion concentration, explaining ionization of water and its dual role as acid and base. Describe the ionic product Kw and pKw for water. Now we will discuss about these terms in detail when it comes. Appreciate use of buffer solutions. Buffer solutions are solutions which do not change their pH when they react with certain chemicals. Otherwise, normal acid or base do change their pH whenever they react with other chemicals of opposite nature or similar nature. Calculate the solubility product constant. So these are our objectives, and in this unit we will discuss multiple different type of mathematical equations as well. But keep in mind concept, if you understand concept properly, then these points or these mathematical terms are easy. So that means you have to understand the topic, then you can explain or calculate the given numericals easily. Now let's start with introduction. Chemical equilibria are important in numerous biological and environmental processes. Now chemical equilibria, that means what equilibria means first. Let's talk about it. So equilibria, that means we can say that balance between the reactants and products or balanced situation of our chemical reactions. For example, equilibria involving O2 molecules and the protein hemoglobin plays a crucial role in transport and delivery of O2 from our lungs to muscles. Similar equilibria involving CO2 molecules and hemoglobin count for toxicity of CO. When a liquid evaporates in a closed container, molecules with relatively high kinetic energy escapes the liquid surface into vapor phase, and number of liquid molecules from the vapor phase strike the liquid surface and are retained in liquid phase. That means what this point is trying to say is, we have suppose container which is airtight, that means closed from top lids as well, and it is filled with a volatile liquid. That means it will releases vapors. So suppose this is the boundary line. Below this boundary line we have liquid state, above this boundary line we have gaseous state of the same liquid. So molecule with higher kinetic energy, that means it has comparatively more amount of energy, will escape from liquid state to gaseous state, and molecules which strikes to the surface, which are initially in gaseous state, will become liquid state. Now when we have closed container like this, then the rate of transformation of liquid to gaseous state and gas to liquid state will be equal. That means two different type of physical reaction is going on inside this container. First reaction is liquid molecules are now becoming gaseous molecules, and gaseous molecules, by striking on the surface of liquid, they are becoming liquid molecules. Now assume that per 1 second 10 molecules of liquid are converted into gas. If same number of gaseous molecules are converting into liquid state in 1 second, then no change in pressure will be observed. That means vapor pressure inside this container as well as quantity of liquid will remain same. So it looks like they are not changing, but reaction is still continue. Both type of reactions are at equal rate. That's why no change in their physical states or no change in their quantities is being observed, but it is not static or steady. Reactions are still going on. So it gives constant concentration or constant vapor pressure because of an equilibrium in which the number of molecules leaving the liquid equals to number of returning to the liquid from the vapor, and they are same, so that's why no change will be observed. We say that system has reached equilibrium state at this stage. Whatever this is not a static equilibrium, and there is a lot of activity at the boundary between the liquid and vapor. Thus, at the equilibrium, rate of evaporation is equal to rate of condensation. Now, condensation, that means conversion of gas into liquid or solid. It may be represented by H2 liquid to H2 vapor, and two half arrows are not printed in this case, so let's see us represent. So the double half arrow indicates that the process in the both directions are going on simultaneously. That means forward reaction as well as backward reaction, both reactions are simultaneous. The mixture of reactant and products in the equilibrium state is called equilibrium mixture, and when equilibrium is attained, concentrations will remain constant, although reaction is still dynamic or it is still going on, but concentration will remain constant because of equal rate of forward and backward reaction. So as mentioned, if 10 molecules of H2 liquid is converting into vapor phase, then 10 molecule will return in liquid state. So overall total number of molecules will remain constant in both states. Equilibrium can be established both physical processes and chemical reactions. The reactions may be fast or slow depending on the experimental conditions and the nature of the reactant. When the reactant in a closed vessel at a particular temperature react to give products, the concentration of reactant keep on decreasing while those of the product keep on increasing for some time. Okay, so initially when we have only reactants inside the container, we are talking about at this point. So when only reactant is present inside the container, then only possible reaction is reactant to product, because we do not have product to get a backward reaction. Okay, so when time is equal to 0, at that time concentration of reactant will be fullest or max. Let us say it is 1 mole, and yet product is to be produced, that's why its concentration is 0. So we can say that only one possible way is forward reaction, reactant to product, because for reverse reaction we need some quantity of product, but we have 0. That's why reverse reaction initially is not possible. But after some time, when we have some amount of product, it will start converting itself into reactant. So you will get backward reaction when you have some quantity of product. After certain time, both reaction rate will become equal. That means reactant to product rate and product to reactant rate will become equal, and at that time we can say that reaction is at equilibrium. So that's why initially reactants concentration will keep on decreasing and products concentration will keep on increasing. And after that, when we have sufficient enough quantity of product, then forward and backward reaction will become equal, or rate of reactions forward and backward will be same, and then no change in their concentrations will be observed, and we can say that equilibrium is attained. Okay, so when no change in concentration is observed, this stage of system is dynamic equilibrium, and the rate of forward and backward reaction will be equal at that time. It is due to this dynamic equilibrium stage that there is no change in the concentration of various species in the reaction mixture. Based on the extent to which the reaction proceeded, the state of chemical equilibrium in the chemical reaction may be classified in three different groups. So first group is the reaction that proceeded nearly to the completion and only negligible concentration of the reactants are left. In some cases, it not even possible to measure or detect concentration of reactant experimentally. So that means first category is almost 100% complete reaction. Majority of reactant will complete in product. Second, reaction in which only small amount of product are formed and most of the reactants remain unchanged at the equilibrium stage. So that means we are talking about very poorly efficient reaction. First case is very highly efficient reaction. Majority product will obtain, minor fraction of reactant will remain. In second category, we have very poor reaction. Majority reaction do not occur. And last, the reaction in which concentration of reactant and product are comparable when the system is in equilibrium. That means we can say that 50-50 condition, almost same concentration of reactant and product, or it may be 60-40 or 70-30 or even 80-20 type ratio, 80% reactant and 20% product, or 20% reactant and 80% product, but still we can easily measure the concentration of both of them. Then it falls in third category. The extent of reaction in equilibrium varies with experimental conditions such as concentration of reactants, temperatures, etc. That means when we change the conditions of the reaction, product quantity will change. Okay, equilibrium change, that means product quantity will change. So some reaction gives good amount of product at higher temperature, some gives good amount of product at lower temperature. So it represents quantity or equilibrium depends on conditions. Optimization of the operational conditions is very important in industries and laboratory so that equilibrium is favorable in the direction of desired product. Some important aspect of equilibrium involving physical and chemical processes are dealt in this unit, along with the equilibrium involving ions in the aqueous solution, which is called ionic equilibrium. So that means suppose you are running a chemical factory, or let us say we are running a pharmacy. That means we are producing some medicines. So that means we need higher amount of product from given reactant. Suppose our reaction is 60% efficient. That means per 1 kg of reactant you are only getting 600 grams of product, and 400 grams of reactant is wastage. So if you find a reaction or a way where you can increase the percentage of reaction, that means we are moving equilibrium point. Let us say we have a reaction which can produce 70% product from given quantity of reactant. That means you will get 700 grams of product from 1 kg reactant. So that means we are changing the position of equilibrium state by increasing pressure or decreasing temperature, whatever we need. So when we change the conditions, we can change the equilibrium point. So our target is to find maximum possible percentage of product. That means it is called optimum state, where our costs are reduced and product quantity is maximized. So we will talk about these points in upcoming lectures, and if you find any difficulty regarding to this basic information, feel free to ask. We will discuss about other points in next lecture. Thank you.